Hello everyone, welcome to another lesson in pre-calc. Today's lesson 2.3 will be on quadratic functions, so let's go ahead and jump right into it. Alright, as you can see, we have 28 questions. First thing I'm going to do is I'm going to go to the textbook, just see what we really need to be absorbing this chapter, look what we're looking for, and so forth. So, let's get through this. Alright. Quadratic functions. If the degree of a linear function is increased by 1, we obtain the second degree function, which is called a quadratic function. Another basic function, one of our parent functions. So here, a quadratic function, equations and inequalities. This is going to be our basic parent function, x squared, which should be shown on the next page. There's x squared. So there are ways that we can move it. We can move it up, down, left, right. We can kind of multiply it, and we get all different kind of things. Alright, so here a quadratic function is a, b, and c are real numbers where a cannot be equal to 0 because then it would be a linear function where it's ax squared plus bx plus c. It's called a parabola. If x is any real number, then ax squared plus b is also a real number according to the agreement on the domain and the range. Yep, so here any number that you plug in will have a value. Moving on. Let's see. To solve for the roots or the solutions for the quadratic equation, you have to use the quadratic formula, which is what we use for everything. Negative b plus or minus square root b squared minus 4ac, all divided by 2a. Just sketching some basic characteristics and then solving for them. Cool, totally cool with that. Using a graphing calculator, totally cool. Solving for the intersections, awesome. How many x-intercepts can the graph of a quadratic function have? 2, 1, or 0. It either touches the graph twice, it touches it once, or it touches it 0 times. Vertex form, so ax squared plus bx plus c can be solved for a parentheses x minus h squared plus k, where a is a multiplier, h and k is the vertex. So that's kind of like where the parabola hits its peak or valley. Let's see. So this right here would be your vertex, your minimum value 4, 8. So it should be x minus 4 parentheses squared plus 8. Remember, parentheses are lying to you, so this graph was actually moved 4 units to the right, 8 units up, and that's what our graph will look like. The line of symmetry, x equals 4, is basically what cuts the graph in half. Okay, this is just a reflection. This is a positive x squared. This one will be a negative x squared. Moving on. Here's a summary of properties of quadratics. This is standard form, vertex form. Parabola's opening up. There's your vertex, your minimum value, and so forth. Let's see. Vertex, axis of symmetry, x is equal to h, the x coordinate of the vertex. F of h is just k, which is the minimum or the maximum value. Domain is going to be all real numbers. Your range is either obviously the low point to infinity or the high point to negative infinity, and so forth. And this is just solving problems. I'm cool with that. Probably into the graph. I'm cool with that. I don't need help with that. And then maximum revenue. So trying to figure out here, I'm guessing there's going to be some kind of quadratic. There's a quadratic. I got to figure out, since it's a negative, this graph will be going down. So I'm looking for that maximum vertex. And then we just got to figure that out, solve that point, use a graphing calculator. I'm cool with that. I'm cool with that. Moving on. Another break even. Just looking to see where the intersection is using the quadratic equation. I'm totally cool with that. Use intersect, use a graphing calculator. Cool, cool, cool. Finding domain, finding range, regression. I saw, was that regression? And find the quadratic regression. So this may be a little tricky because Desmos can do it. That's gonna be my least familiar area. How to do a quadratic regression on Desmos. Alright, and that's pretty much it, I think, right? Yep, then it goes into the problems and so forth. So, alright, here we go. Find the vertex of the form of the quadratic function by completing the square. So, by completing the square, that means they want you to get this into vertex form. So if you think about this, how am I gonna, probably the best thing would just be Desmos and look at a lot of these in the Desmos way. Okay. To complete the square, I need a term to be here. So the question is, what would this need to be in order to be perfect? So what you would do is you would take your b term, divide it by 2, and then square it. So I'm going to go to view an example because it's going to show us. So when you get into that form, yep. Okay. So here, the negative 12 is our b term. This would be ax squared, 1x squared plus bx, so b is negative 12, and then plus c. We're missing the c. So you take your b, divide it by 2, and then square it. So negative 12 divided by 2 is 6. 6 squared is 36. So I'm going to add 36 to the left and add 36 to the right. Or they just kind of did it like that so that it balances the equation. Now, this x squared minus 12x plus 36 is going to be x minus 6 squared. Boom. And now if you look at this equation has a vertex of 6 to the right, 36 down. So, find the vertex form of the equation. So here, if you take 6 divided by 2, that's 9. 6 divided by 2 is 3. 3 squared is 9. And then that becomes parentheses, my keyboard's not on, parentheses x minus 3 squared plus 9. Plus 9. Minus 9 because the plus goes on the inside to factor it out. Minus. There we go. Sorry. When you multiply, yeah, the plus 9 is on the inside. Okay. So here, same exact thing, completing the square to find the vertex form of the quadratic equation. So with this one, I'm going to want this to be 100. So if I break this up into 102, what that gives me on the inside is 10. No, I want that to be divided by 2 is 5. That's 25. So 25 and 77. So let's try this as x minus 5 squared, and then 25, 102 minus 25 is 77. So then that should be plus 77. There we go. Alright, so now here what you'd have to do is factor out the negative 1. Now now that hopefully if you guys see, I'm just going to give you an example. It's the same exact thing. You find this, you do that, you complete that square by adding it to both sides, and then you continue. Now if we have Desmos, what I should be able to do is just go in here, open this calculator, type in negative x squared plus 10x minus 95, find this vertex, and then just go x minus 5 squared minus 70. Oh, my bad. There's a negative 1, so it's a negative x squared, and then I think everything else is exactly the same. Yep, I forgot the negative because it's going down. This graph is going down. So that should be kind of like an easier way. So now here, describe the relationship between x squared plus 2x minus 3. So you guys can just kind of take that out. X squared plus 2x minus 3 minus 3. And you can see that if I go to the vertex, this graph was moved to the right 1 unit. I'm sorry, left 1 unit and down 4. So this graph went left 1 unit and shifted down 4. Pretty simple. Alright, now you're going to match each one. Some of these are x squared, which one is going negative, going down. So pretty straightforward, 4 parts. This one's going to be a negative, move to the right. What's the pink graph? D? I can't see, what is that? That's n. So this first one's going to be n. And then you just kind of go through it and figure out all of them. Moving on. Alright, use the graph to find this. So here, if we just zoom this in, state the x-intercepts. Oh, I can't see the x-intercepts. What if I do that? My x-intercepts are 1, 2, 3, 1 and 3. So here, I'm just going to state them as numbers with a comma, 1, comma 3. Check answer. Awesome. State the y-intercept. Open this graph back up. Where does it touch the y-axis? That's 5, 4, 3. So that's going to be at y equals 3. The y-intercept is the coordinate. Use a comma. Oh, negative 3, sorry. Oops. Not negative, negative 3. 3, 3. No, my 3 doesn't work. 3. There we go. So now my vertex, where's the vertex located here? It's at 1, 2, 2, 1. So 2, 1 is going to be an ordered pair because it's a coordinate. Awesome. This function has a maximum value of 1. Highest value you can put up. The range is going to be from the lowest value. Now, since this graph is facing down, it's always going to be the same exact thing. It's going to be negative infinity to our highest point, which here in our range is 1. So every y value from negative infinity to 1 works. This touches, so it gets a hard bracket. Wrong one, that one. There we go. Cool. Moving on. So here, in this function, find the intercepts, the vertex, maximum, minimum, the range. So right off the bat, I can tell you that if you plug in 0 for here, it's going to give you what the y-intercept. So if I plug in 0, 0 plus 9 is 9. 9 squared is 81. Negative 81 plus 9 is going to be negative 72. So that's going to be negative 72. The x-intercepts. To find the x-intercepts, my best bet is probably just take a look at this graph and see what's going on. So negative parentheses x plus 9, close the parentheses, square it, and then add 9. So here, there should be negative 6 and negative 12. So I can now just use a comma to say negative 12, comma, negative 6. Check answer. Awesome. What's my vertex? That point right there, negative 9, 9, comma 9, 9, parentheses, close, enter, sick. This function has because this is a peak, this has a maximum value. Awesome. The maximum value should be the y-coordinate of your vertex, which is 9, and your range, because this graph goes from negative infinity all the way up to 9, hard bracket, enter. Cool, and that was the entire question. Awesome. So I'm guessing this is going to be the same exact thing, guys. Very similarly, just going to make that x minus 1 squared plus 7. And as you can see, I got all my informations there, and then there could be no y-intercept. So here, this is going to be 8. The y-intercept is 0, 8. Type in integer or decimal around to 2 decimal places as needed. The y-intercept is 0, 8. Is that not? Oh, it's minus 7. I'm sorry, I typed in the wrong equation. Negative 6. No problem. Negative 6. Negative 6. So yeah, this is pretty much the same exact equation like the previous. The vertex. Oh, look at those. We got decimals. What? Round to 2 decimal places. Awesome. Moving on. Write an equation for the graph here where it's either negative 1 or positive, where a is either negative 1 or positive 1. Okay, so here if we look at this, all we need is the vertex, which looks to be 1, 2, 3, negative 3, 2. And if you keep that in mind, this graph is going down, and then it's x plus 3 because it's lying to you, and squared, and then I said plus 2 because it's telling you the truth. Did I switch them? Was it 2 and 3? Negative 1, 2, 3, 1, 2, 3, 4, 5. I think negative plus 3, plus 3, plus 2, plus 3, plus 2, negative x plus. Oh, type an equation. You guys, come on, computer. Y equals, there it is. I was like, how do you, same exact thing here. Moving on. The vertex, so here, same exact thing. Let's just type that in. Let's take a look at this, what this looks like. So there's no surprises. X squared minus 10x, and then plus 21. So my vertex looks like to be a nice number. Nice numbers. Vertex minimum range, easy. Here, so let's make this 0.5x squared, 0.5x squared, and then minus 4, and then plus 9. Plus 9. Alright, so now here, intercepts, you're going to have the y. There are no x-intercepts if I typed it incorrectly. 0.5x squared minus 4. Yep. Minimum value, range. Awesome. Cool. So first it wants this in vertex form. You could write that. I see no problems here. It should be pretty straightforward. Moving on. So here, solve the equation for g of x is equal to -8. That means they want to know where this graph intersects. So if I type this point, so what is that? -0.6, -0.6 x squared plus, yeah, go here, plus 3x plus 6. And then my graph is going to be -8. My second equation, what's this be? Y equals, right? Y equals, and then this is y equals, and then I'm looking for those two solutions right there. Use a comma round to 4 decimal places. So if I do -2.9391, comma 7.9391. Yeah, it's not decimals. All good. Decimals is amazing. All right, find the minimum value to 4 decimal places, type the equation in, and then I'm sure you're just going to find the vertex. So what is that? That's 300x. I type the 300x minus 5x squared minus 2. So what am I looking for? The maximum value. The maximum value, (4498). We got this. Cool. Moving on. All right, write the function, then find the vertex. What's the intercept? Choose the correct vertex form below of this equation. Plug it in. You guys got that. Moving on. Find the intercepts, the vertex. Easy. Use the interval notation to write the solution set of the inequality. So here, let's take a look at what this is, right? Let's see, x squared plus 4x minus 5 is going to be less than or equal to, can I do less than 0? Let's go back to the home. I mean, x squared plus 4x minus 5 is less than 0. Oh, absolutely. It's this number, -5 and 1. Now because it's in between those, all we gotta do, type an interval notation. Now I couldn't do the underline, so I'm just gonna put a hard bracket at -5, comma 1. Hard bracket. 1, -5. Did I put a period right there? Is that a period? It looked like a period. Yep. Okay, so let me show you how to solve this one a different way. Let's go to the view an example. First, what you would do is you would solve it as like an inequality, like a fraction, not a fraction, factoring it. So x squared plus x minus 56 is going to be 9 and 8. 7 and 8, I'm sorry. So then you get x minus 7, x plus 8, and then you would set each of these equal to 0 or less than or equal to, right? So I usually set it equal to 0 because I'm going to put on a number line so that I know that it's going to be the intervals between -8 and 7. And then here they're going to say they're going to test a point on the number line, right? And they're going to see if it satisfies the equation. And then they're just testing points, testing, seeing if it works, and so forth. So if I were to translate that over to decimals, like all you need is the numbers, -5 and 1, and then you test the number on the outside. So if you plug in -6 into this equation, you get 36 minus 24 minus 5 is bigger than, it's going to be a positive number, so it's not going to make it true. Same thing with numbers bigger than 1, and it only works for numbers in here, like 0, 0, 0, -5. -5 is less than 0, so it makes it true. And that's how we got that interval. All right, solve for the inequality using a graphing calculator. Let's see if I can do the same exact thing. So if I do 1.8x squared minus 1.1x minus the 5.2, and then if I put that equal to less than 0, When I graph it, I get these two numbers. I get that and that, round to 2 decimal places. So if I were to do this is not equal to, so it should be parentheses, negative 1.42, comma 2.03. 2.0, that 3 button is not working, so 2.03, and again this is going to be parentheses, hit enter, got it, cool, moving on. So now here we just got to figure this out, and you can really just graph it and see what that looks like and then fill in these two inequalities. So let's just take a peek. So here we go, we have 2.2 plus 3.3x minus 0.6x squared. And when is that greater? When is this less than 0? So it's going to be less than 0 from negative infinity to negative 0.6. And when x is bigger than, so when x is less than negative 0.6, how many decimal points? 2 decimal places, 60. Or when x is greater than, what's that number right there? 6.10. 6.10. Cool. It's the outside regions. Given that f is a quadratic with a minimum there, find the axis, vertex, and all that. Well, this is the minimum, which means this is going to be the point 1, comma 3. So my axis of symmetry is going to be x equals 1. And then my vertex is 1, comma 3. And then my range with a minimum value, which means this graph is going up. So my range is going to be from that value, hard bracket 3 to infinity with a parentheses next to it. So I just need an infinity symbol right there. So my range is going from there up. Check answer, and then it's going to probably ask for the equation. What are the x-intercepts? There are none because this graph is at 1, comma 3 in the positive direction. So yeah. Okay. Now here we let f of x equal that function, g of x equals that function, graph f and g on the same interval. Okay. Negative 0.9x parentheses x minus 8. X minus 8 parentheses, and then g of x, which is going to be 1.4x plus 5.1. So now that I have those two graphs right there, what does this look like? Well, it goes up to 15. So I'm thinking maybe this one. It looks like it intersects right around 5. 0, 5 should be right around there. I'm thinking this one. It's either this one or this one. I'm thinking this one. Cool. Okay, what's the next part? I'm assuming f of x equals g of x at the points there and there. So not ideal because they're decimals, but we can get them literally by clicking there and by clicking there. So my round to 2 decimal places, 1.05, comma 5.39. Those are my two solutions. Continue. For what value of x is f of x bigger than g of x? I think f of x is this one. When is purple? Well, it's in between those two values, right? It's in between. When x is between 1.05 and 5.39. Cool. And the last question is when is f of x less than outside of those values? Between 0, 1.5 and between 5.39 and 8. There we go. Next question. Same exact thing. This is going to be a negative x squared. This is a positive x squared, positive 5, 1.4, negative. It's going to be, I'm going to go with C. No? Where's 5? 5 should be right around there. There we go. All right, just picking the graph it. Again, okay, so here, what? Find the 2 points where they're equal to each other, find when it's less than, find when it's greater than, same exact questions. I'm moving on. How can you tell if the graph from the quadratic function whether it has two real zeros? If it touches the x-axis, twice, the graph of the function passes through the origin. Has the graph of the function intersects the x-axis twice, has two real zeros. There we go. How can you tell from the standard y equals ax squared plus bx where the quadratic touches it has exactly one real zero? So here you'd have to use the discriminant, and the discriminant says that when you plug in b squared minus 4ac, if it's equal to 0, there's one solution. So that's when it's equal to 0. If it's a positive number, there's two solutions. If it's a negative number, there's one solution. I'm sorry, if it's negative number, there's no solutions. No real solutions means that you're going to have, oh, this is vertex form. How can you tell from vertex form whether the quadratic function has no real zeros? If a is positive and k is positive. If a is positive and k is positive, so if a and k match the same signs, then it's game over. No real zeros if a is positive and k is positive, or a is negative and k is negative, because that means that your graph is moving up and smiling or moving down and frowning. They're never going to intersect the x-axis. In order to move the tire, so here we need to get regression. Copy to clipboard. Here's where it's going to get interesting. Can I just paste this in Desmos? And then can I do add regression, and can I put it as a quadratic regression? Does that work? And then can I just say that it's going to be 3 decimal places, huh? Negative 0.571 parentheses x should be 36.571, and then negative 530.971. Dang, all the ones. I hope this is right. Let's see. Oh, fantastic. Sick. Cool. So again, using regression, copy paste it, get the table, click the 3 dots over there. You can open regression. Awesome. Okay, so we founded the marketing research department for a company that manufactures and sells money clips for microcomputers. Establish the following price, demand, and revenue functions. There's my price demand, there's my revenue function, where P of X and the wholesale of that. Which of the following is the graph of the revenue function? Revenue is going to be a negative x squared. So you can see negative 3x squared, so the graph should be going like this. Revenue is going to start at 150 and then be going down. So I'm thinking it's going to look something like A. Correct answer is C. 150. Oh, the graph. That was sneaky. The graph is the other way around. It should have been positive x values. Oh, that was dumb. That was dumb. These are negative x values. That was dumb. Find the output that would produce the maximum revenue. So then you would set that equal to, you'd find the peak. So let's see. That's going to be x parentheses 115 minus 3x. Close the parentheses. And let me go to Desmos, and I see the value, obviously, so it's somewhere up there. Oh my goodness, where is it? It's right there. What's that value? How many million chips? 19 point, how many decimal places do you want? Type in integer or a fraction. 19 1/6. Wait. Find the output that will produce the maximum revenue. I think, what if I just do 19 million chips? Is that going to accept it? No. What is that? 2/8? No, not 2/8. Is that 1/8? What's 1/8? 1 divided by 8 is 0.125. What gives me 0.16? 0.16. Dang it, up here. 0.16 as a fraction is what? 4/25. 25. That's not what I'm looking for though. 0.166666666. I can only do how many? 83. I don't know what that decimal is. Type in. What's 1/6? That's it. 1/6. 1/6. 1/6. 1/6. What's 19 and 1/6 gonna be? 19 times 6. 19 times 6. 19 times 6. 140. 114. 114 plus 1 is 115. 115 over 6. Oh my god, sometimes I do so much work. So, there's a formula for the axis of symmetry. Let me see if it gives it right here. Negative b over 2a. Distribute through x. Get it in vertex form. You could just do negative b over 2a. That gives you the value. Negative b, which would be negative 115 over negative 2 times 3, which is 6. 11 over that. And then our maximum value, rounded to 2 decimal places, is going to be 1102.08 million dollars. All right, what is the wholesale price per chip that produces the maximum revenue? So then what would the price be? It would be that number plugged into there. What is the wholesale price per chip that produces the maximum revenue? Is this where? What is the wholesale price per chip? I've made that many chips, so I take that divided by that, correct? I would take 1102.08, divide that by the parentheses. I could do 115 divided by 6, and that's going to tell me how much it costs. I've made that many million. It cost me $57.81 per chip. $57.81 per chip. What's the wholesale price per chip that produces the maximum revenue? If I plug that into that, then it's 115 divided by 2. Not 5 divided by 2, so 57.5. Round to the nearest dollar. You son of a guns. 58. They're both answers are 58. No. Oh my goodness. Both of them were. Yep. 58. Okay. So I think, yeah, that should have made sense. Right? Show completed. Just do that one more time. The maximum revenue, it comes into this number divided by 2 times that. And then that gives you the maximum revenue. And then you just divide those two numbers to figure out how much it costs per chip. Okay. 2 more questions. The French physician Poisson was the first to discover that blood flows faster near the center of an artery than near the edge. Experimental evidence has shown that the rate of flow in centimeters at point blank is given by that. Find the distance from the center of that is the rate of blank flow of 25 centimeters per second. Find the distance from the center. So let's first get rid of all of this. So first, let's write our equation. We have 1,000 parentheses 0.04 minus x squared. So there's my first equation, right? We can close that. And then our second is going to be that it's 25, right? We're looking for when this is equal to y equals 25. And then I can say that y is also equal to the set equation. And now, here we go. So if we look at this, this is my distance from the artery. My speed is at 25, which happens twice. It happens at negative 1.2 and positive 1.2, and obviously, that since we're talking about distance, you are going to be a total distance of 0.10 hundredths. 0.12, what is our unit? Centimeters. There we go. Cool. Last question. Table here, find the quadratic regression. Okay, let me copy this to my clipboard. Let me delete this. Let me delete this. Let me copy that. Let me take this. Let's go ahead and paste that into here. Let's run a quadratic regression on this. And what are these values? Round to the nearest tenth as needed. E to the negative 6. So that's going to be 1, 2, 3. Oh my God. 1, 2, 3, 4, 5, 6. So 1.3. 1.3 e to the negative 6. Round to at least 5 decimals. Negative 0.12, 3, 4, 5. And C round to the nearest tenth, 4.8. 7, boom, be 4.8. My goodness, these are some crazy numbers, but I got it, first try. Awesome. Oh, what is the estimated boat speed of an engine with 3,100 revolutions? Can I just put in, this is an X value, 3,100, and will it give me an answer? Come on. Wait a minute, let's do X equals 3,100. Boom. 10 points to the nearest tenth. So let's go 10.7 miles per hour. Oh, nice. Cool. And now we are officially done. Awesome. And that completes 2.3 quadratic functions. Good luck.